Student, today our topic is vector or cross product. Definition: let A and B be two non-zero, non-parallel vector. Then the vector product A vector cross B vector is equal to magnitude of A vector, magnitude of B vector into sine theta n cap vector. Here n cap is a unit vector. Magnitude of A, magnitude of B, sine theta is a magnitude of a vector product, and n cap is a unit vector perpendicular to plane of vector A and vector B. Here there is a vector, or this is a V vector, and theta is a angle between them, and n cap is a unit vector perpendicular to the plane of vector A and vector of B. Student, in the cross product, this is a magnitude part, this is a short direction, so cross product is a vector product. Student, now we are doing important points. I cap cross I cap is equal to magnitude of I cap multiply magnitude of I cap sine 0 degree j cap. Here I cap into I cap angle is 0, so sine 0 is 0. Similarly, j cap cross j cap is equal to k cap cross k cap is equal to 0, because sine 0 is 0. Now we are cross product of I cap cross j cap is equal to magnitude of I cap into magnitude of j cap sine 90 degree and k cap. Here sine 90 is equal to 1, or magnitude of I as well as magnitude of j cap is equal to also 1, so its value is k cap. Similarly, j cap cross k cap is equal to I cap, k cap cross I cap is equal to j cap. Student, here we are taking j cap vector since j cap is perpendicular to I cap vector, and also this is a unit vector. Now we are taking here k cap since k cap is perpendicular to both I and j, and it is a unit vector. Similarly, we are taking here is I cap and j cap. What if we find the j cap cross I cap, then it is equal to minus k cap, since the angle between j and I is 270, and 270 is equal to minus 1. Similarly, if we find the cross product of k cap cross j cap is equal to minus I cap, since angle between k cap and j cap is 270. And similarly, I cap cross k cap is equal to minus j cap, since there is angle between I cap and k cap is equal to 270, and 270 is equal to minus 1. Student, now we are find the vector product in term of components. Let A vector is equal to a1 I cap plus a2 j cap plus a3 k cap, and V vector is equal to v1 I cap, v2 j cap and v3 k cap be two vectors. Then A vector cross B vector is equal to this, and B vector is equal to this. Now we find the a1 I cap cross product with this vector, we get this, and we find the cross product of a2 j cap with this vector, we get this up to this. Then we find the cross product a3 k cap with this vector, we get this. Now we using important points I cap into I cap, j cap into j cap, k cap into k cap is equal to 0. Student, by using this important formula, we get A vector cross B vector is equal to a1 b2 k cap plus a1 v3 minus j cap plus a2 v1 minus k cap plus a2 v3 k cap plus a3 v1 j cap plus a3 v2 minus k cap by using these important points. Now we are find the coefficient of I cap and coefficient of j cap, coefficient k cap by common Student, by using these important points, we are get a vector cross v vector is equal to a1 b2 k cap plus a1 v3 minus j cap plus a2 v1 minus k cap plus a2 v3 I cap plus a3 v1 j cap plus a3 v2 minus I cap. On solving this, we get coefficient of I cap a2 v3 minus a3 b2 I cap minus coefficient of j cap a1 b3 minus a3 v1 j cap plus a1 v2 minus a2 v1 k cap. On solving this, we get a vector cross b vector is equal to determinant of I cap, j cap, k cap for these points. This is a formula to find the cross product of a given component. Students, now we are find the cross product with examples. Let find a vector cross b vector if a vector is equal to 2 I cap plus k cap and v vector is equal to I cap, j cap plus k cap. Now solution is a vector is equal to 2 I cap plus 0 j cap plus k cap and v vector is equal to I cap plus j cap plus k cap. Now we find the solution. A cap cross b cap is equal to, by the formula, I cap, j cap, k cap. Now this is a coefficient of a vector or this is a coefficient of v vector. Now by solving the determinant, we are leaving first row and first column, we get submatrix this, and second we leaving the first row and second column we get this, and last we leaving the first row and third column we get this. On solving this, 0 into 1 is equal to 0, 1 into 1 is minus 1 and minus j. Or on solving this, 2 into 1 is equal to 2, 1 into 1 is minus 1 and on solving this, k cap 2 into 1 is 2, 1 into 0 is equal to 0. On solving this, a vector cross. Students, on solving this, we get minus I cap minus j cap plus 2k cap. This is solved by determinant method. Now if we find the magnitude of this vector, then this is equal to square root of coefficient of I cap plus coefficient of j cap plus coefficient of k cap. On doing square of minus 1 we get 1, on doing square minus 1 is equal to again 1 and on doing square of 2 is equal to 4. On solving this we get under root 6. Students, now we are doing another examples. Find the magnitude of a vector given by a vector is equal to I cap plus 3j cap minus 2k cap cross product with minus I cap plus 3k cap. The solution is a vector is equal to this vector and this vector. Now we find the cross product with the determinant method. This is I cap, j cap and k cap. This is a coefficient of this vector or this is a coefficient of this vector. On solving this, we determinant method, we are leaving first row and first column, we get this submatrix. On solving first row and second column we get this, or on solving first row and third column we get this. On solving this we get 3 into 3 is 9, 0 into minus 2 is equal to 0 and 3 into 1 is 3, minus 1 into minus 2 is equal to minus 2. On solving this we get 1 into 0 is 0, minus 1 into 3 is 3. On solving this we get a vector is equal to 9 I cap plus 3 j cap plus 3 k cap. We find the magnitude of a vector by the square root of sum of square of coefficient of I cap, square of coefficient of j cap, square of coefficient of k cap. Solving this, we get 9 square is equal to 81, 1 square is equal to 1, 3 square is 9. On solving this, we get square root of 91. Thanks.